And so we'll get started today. We're going to be looking at rest machining. That's going to be on 3-axis milling. And that's only found in the 3-axis Pro license. So if we go to File, Help, and down at the bottom you'll see Show License Status. That's to see and make sure that you guys have Mill 3-axis Pro on your license. You'll see all the checkboxes here. Here it starts with CAD, Mill Express for 2-axis milling, and then getting into 3-axis milling is Mill 3-axis Standard and Mill 3-axis Pro. That's the one you need unlocked to be viewing what we're going over today. And so I'm just starting off with a milling job where I have some drilled holes to start with. And then we'll be getting into 3-axis milling for this part file here. And I start with right-clicking on Machine Setup 1 and going to Mill 3-axis. Select my geometry and select my boundary. So for the geometry and 3-axis milling, I'm selecting the 3D model to make sure there's no collisions or gouging into the 3D model here. And then for the boundary, I'm selecting the surface edges here for the toolpath to be contained inside of that area. And so in the Mill 3-axis, under the machining strategy page, we can see the available operations on the right-hand side. Under available operations, the first 6 is the Mill 3-axis standard milling operations: Z-level rough, Z-level finish, planer for a finish operation, back and forth, spiral, radial, and plunge rough. And below that are our Mill 3-axis Pro milling operations. So you can see advanced rough, the advanced finish, advanced planer. And then our other 3-axis finish operations are going to be flatlands to mill any flat areas on a 3D model with a flat end mill. Equidistant is our spiral toolpath. Pencil to mill any fillets, and project curves where I can project a 2D shape onto a 3D surface. And so we're looking at advanced rough today with our rest machining. We select our tool next. I'm just going to be using a 1/2-inch flat end mill. Next page, we're setting our cut pattern. It could be any of these options here for the rest machining, but we'll be looking at the adaptive roughing, which is our high-speed machining milling operation, keeping constant tool engagement. Our other 3-axis cut patterns, we have parallel, which will just zigzag back and forth inside of a pocket, offset out from the center towards the sidewalls, offset in from the outside, and more spiral and adaptive roughing are our high-speed machining options, just spiraling out from the center. And I'm just going to mention all the changes that I'm making here. So selecting adaptive roughing, selecting zigzag so that it uses both sides of the tool, you could say, just back and forth zigzag. We have our depth of cut and step over mounts. And yeah, I'm really not changing anything on this page. My next page will be setting how I want to enter into the stock. And I'm just leaving it at the plunge option for now. Here's our rest machining page. So we have rest roughing. If I used a previous tool, a larger tool, let's say like a 7/8 tool, I can type in 7/8 here and type in the corner diameter of that tool. The software will calculate any areas the previous tool couldn't fit into and calculate that tool path for us. So essentially it'll start right where we left off from the previous operation and avoid any air cutting. Machine flatlands would come back and machine any flat areas on the part to finish those up. We have linking for each step over, our gauge check page, advanced feed rates to set a constant chip load for the adaptive feed rates, and MDI for manual data input. I could add G-code before or after the operation here. So I'm just going to hit compute. And as I mentioned, our rest our rest roughing operation here, it'll compute the tool path based on the tool that I used and the 7/8 tool, and then just calculate the tool path from there with the 1/2" tool. I'm going to turn that on. I'm going to turn that off, and then we have other selections for rest machining options from there. After I've hit compute, you can see in the CAM tree, under the feature, and under the feature, and then under the operation under advanced rough, I can expand those options, where I have a boundary option for the advanced rough in particular, so you can set boundaries for specific operations. Under that is drill tip positions. We'll get into that topic next. But first we're going into operation stock. So that is very similar to the rest machining option. We'll take a look at that option after I've simulated everything. So I go to the top and I go to Start Simulation. Let me try it again here. I'll hit Start Simulation. It'll open up in a separate window like this in our newer version here, and I can hit Run. It's going to run the drilling operations first. Then our 3-axis milling operation with the advanced rough. And let's say this is the stock that I'm left with. I want to use this stock as my next milling operation. I can go down to the bottom right corner, and you can see this first page down at the bottom right corner, this first tab called Cut Sim, where my cursor is down at the bottom here. I open up that tab, Cut Sim, and then I can hit this Save button. I can save the stock at its recent state here. I'm going to save it in my Downloads folder. I can name it whatever I want here. I'll name it Webinar. I think I already have it saved. Another file saved as Webinar. I'll name it Webinar 1 and hit Save. So when I close out of simulation, under the CAM tree, and then under that operation under Advanced Rough, where we see Boundary, Drill Tip Position, and Operation Stock, I can right-click on Operation Stock and reselect. And then I can select an STL model over here. I go to Browse. I browse for the file on my computer, look in my downloads, and I open up that last file that I had saved, webinar1.stl, and then hit OK. Now when I blink everything out, and if I blink out the 3D model here as well, I can click on Operation Stock and it will highlight the operation stock for me. So this is the stock that I'm starting from for my next operation. So it's a really convenient tool to be able to simulate everything that I've machined and then be able to save that stock to load it in for my next operation. Then when I go into, let's say, my next let's say if I recompute it, it's not going to compute any toolpath because it sees that the operation stock is already cut to everything. It's just going to try to machine what it can here in the bottleneck area. But it's a great option here. Let's say if I do another advanced rough, or let's do that. So I'll turn off the operation stock for this one. I'll create another advanced rough here from my machining strategy. For the next advanced rough, let's do a 1/4 inch tool. Let's do the adaptive roughing again. Just to create some tool path, let's do a depth of cut and a step over of 20 thousandths. No allowance on the sidewalls. And then I'm going to hit finish on this one. So that way it saves the changes, but I'm not recomputing. I don't have to recompute this first advanced rough because it's already computed to what it needs to be. I can right click, excuse me, I can right click on an operation under each feature and I can compute an operation individually like this. And that way I won't have to recompute all of the operations in the feature all over again. I can just compute one individually. Before I compute this, actually, I need to select my operation stock, which is the STL file that I had saved. Click OK, and then we'll recompute that second advanced rough. And then we can see in the second advanced rough, it's not pocketing any of this area in the center. Hard to see with all the toolpath there. But you can see here in this isometric view that all of this toolpath is sort of taken away and it's just roughing on the areas from my operation stock here. All right, so we'll get into the next topic of the drill tip positions in that category, those options here under your advanced rough. Next one is drill tip positions. So with my toolpath, it's just going to start sort of, I guess you can see where it wants to. It's starting in this area here where my cursor is. And I can see where it's starting exactly by right-clicking on the advanced rough and going to backplot. That way I can see the tool position where it's going to start, and I can play through it and see the backplot of the toolpath. And I can have it start at a different location by plotting a point in the CAD geometry and selecting that point as my position I want to plunge down in. So if I've already drilled a hole closer up here in, towards the bottleneck of the bottle, I can plot a point there and have the milling tool plunge into that area at each depth so that it starts where I've already drilled that hole. So let's do that. I'm going to go to Create 2D, go to Point, and plot a point. See, I got to measure it out here. About 6 inches, we'll say 5.5 by 4. So I'll go X 5.5, Y 4, and I believe it has to be at the specific depth so that it goes to that position at each depth. Let me just double check that to see if that's correct. So under the advanced rough, I right click on drill tip positions, reselect, click on the point and click OK. And then I can recompute the toolpath. No, looks like in our newer versions here, you don't have to set it at a specific depth. It could be just at the XY position, and it's at Z0. So when I click on it, it's going to start at that position and plunge down from there. Yep. Nope, at the next depth it's starting down in this area. So you do have to set it at the right depth. So what I'm going to do is go to Evaluate, Measure 1, and select that. Find that depth here of 1 inch. So I go to Utilities, translate the point down 1 inch here. Click OK. Go back to my cam tree, right click on drill tip positions and reselect that point here. And then recompute. Yep, now you can see everything shifts over now. So that's a good detail where the point has to be at the specific depth that you're going down to in this pocket, because maybe Bobcat thinks, okay, you've only drilled down maybe 1/4 of an inch and just do the first depth at that location. So you can you have to plot the point at the specific depth so that it drops down into that hole at every location. And let's even make that drilling operation here as well so that we can see it all in simulation. So I'm going to mill drill hole, select geometry, just selecting the point there, and clicking OK. My end mill is a 1/2 inch end mill, so let's make the hole 3/4 of an inch. I'm going to say diameter 750, depth, let's say 750. Hole, we're not going to do a center drill, we'll just do the drilling operation. We'll select a 3/4 inch drill and we'll select a pecking option here. Just want to make sure that it doesn't go further than that in here. So you can see in the parameters, the effective depth that it set was 800. And the reason for that is because on the first page of drilling, instead of having a blind hole, I have it as a through hole. So when you select through hole here, it does an extra 50 thousandths. So I'll change it to blind so that it starts, so that the effective depth is 750. But you can also see that the overall depth is 975, and the reason for that is because of the drill geometry here. The point angle of 118 degrees is making it try to go to 975. I want the overall depth to be 750, so I'm just changing it right here. And you can see the effective depth now is about a 1/2 inch based on the tool geometry there. And I'll hit compute. Alrighty, and then you can see that the drilling operation is down at the bottom here. I can drag and drop it above the 3-axis milling to change the order of operations in the cam tree here. And then we'll simulate again. There we go. So simulation opens. It's going to do all the center drill operations and then the drilling operations next. I'm going to slow it down here. So you can see the drilling operation first, and with the drill tip position option, it starts in the hole and then it's going to work its way out with the 3-axis milling operation from there at each depth. So yeah, the topic is milling with rest machining, save time, reduce wear. You can see this is a great way to reduce wear on the tool. Instead of using the end mill to plunge down into the stock, it's going to start in that hole and work its way out from there with the side of the tool. Those are the main topics to cover today. If you guys have any questions, let me know in the comments section. More than happy to answer anything there. But these were the main topics to cover today on rest machining. Rest machining can also be found in the finish operation, so we'll take a look at that next and see if you guys have any questions from there. So I'll close out a simulation. And next one is rest machining for a finish operation. It's going to be found on the same page as the rest roughing. So if I go back to the 3-axis feature, go to my machining strategy, I go to advanced Z-level finish and add that in. And that's going to be found under the options page. Actually, yes, options page. Just like the rest roughing is found at the top of the options page, but here in the advanced Z-level finish, it's found down at the bottom here under other. Check the box rest finishing, and you can see there's a few options here for rest finishing. Tool from previous operation. It has these numbers grayed out because it calculates the previous tool from the previous operation. The advanced rough is a 1/2 inch flat end mill, so that's what it has set by default. Expand rest area, you can make the area a little bit larger, so you can start maybe one step over, or one amount of the step over that you've set. It'll start from there and work its way in. Next one, user defined tool, so you can type in the number if you want to. If it was a previous operation, maybe you've done it by hand, or you didn't set it in Bobcat, maybe a different software program that you set the roughing operation in, you can set the tool yourself, or stock STL, and then you can click rest stock STL here, and then select your STL file that you had saved from simulation.
You have the program, we can look at that.
And then the other options here, other than selecting your STL file, you can expand the rest area. And then the other one is detect thicker than, and that is a similar option where you can set, maybe if there's more than 5 thousandths, you can set that and it will machine anything that's more than 5 thousandths from your workpiece that you have defined from the CAM tree, your finished 3D model. So that is where the operation stock is found in the roughing operation. It's also found in the CAM tree, just like under the advanced rough. When you expand the advanced Z-level finish, you have your boundary for your Z-level finish specifically. The boundary at the very top under feature 3-axis is the boundary for the feature itself, which would be sort of like, I don't know, I call it the master boundary. It's going to be set for every milling operation below it, but then you can define a boundary specifically for each operation under each operation here. Then we set the operation stock and rest finishing stock here. So that's where your operation stock is found under the Z-level finish. Technically the advanced Z-level finish. The standard Z-level finish, which is found in the Mill 3-axis standard, again, that doesn't have these options. It's just a sort of a basic 3-axis milling operation found in the Mill 3-axis standard. These options are all found in the Mill 3-axis Pro with your advanced rough and your advanced Z-level finish. I'm going to compute it just to see what that looks like. that looks decent. I usually don't use an advanced Z-level finish on this. I usually use an advanced planer to go back and forth across the surfaces. I guess I can sort of go over that with our extra time that we have today. The Z-level finish only follows along any curved surfaces like this, or any tapered walls. It doesn't follow along any flat areas or any vertical walls. So that's why I normally use either the planar toolpath to go back and forth, or the equidistant toolpath for sort of a spiral milling operation in your 3-axis Pro operations. Here's your Z-level finish. See, it doesn't finish up a whole lot there. I have to go in and set the tool with a corner radius, so I'll do a 1/2-inch ball and mill, and I can set my constant depth here, a depth of cut. Instead of 100 thousandths, we could set, I don't know, let's do 10.
Yeah, B27 is probably
and
something.
I'm going to compute the advanced Z-level finish from there. You can see that it doesn't do any flat areas at the bottom. So the planar toolpath is usually the one that I use with this one. But we can see how much material is remaining in the Z-level finish. And then we can test out the planar toolpath and see how much material is remaining from there. I'm going to skip all the drilling operations by just hitting Next Op up at the top of simulation here. And we get to our Z-level finish. Here's another one in our simulation that can be really useful to view how much material is remaining. So that's the tab right next to the Cut Sim tab down at the bottom. It's labeled Analysis. And in the drop-down, I can select Deviation in this page. After I select Deviation, I click on the Refresh button next to it, and it will load different colors on the stock depending on how much material is remaining. So I zoom in and I can see everything in green is cut to size with a cut tolerance with plus or minus 8 thousandths of an inch. And if I zoom in, I can see down here at this floor, the teal color here is 8 to 26, and the light blue color here is 26 to 45 that are remaining. So I'd want to use a different milling operation to finish down at the bottom here, and maybe I might want to use a smaller tool to get into the corners here. But it's a great verification tool to make sure everything's cut to size before we run it on the machine. So I'm going to edit the feature again. Go to my machining strategy and delete the Z-level rough. I'm sorry, delete the Z-level finish. Go to Advanced Planer and add that in. And the Advanced Planer, just like all the finish milling operations, under the options page, they're all going to have a rest finishing option. But we're not setting that for this one. I'm just setting a 1/4-inch ball and mill for the tool. I am setting zigzag cut pattern, and we're going to do lace angle of 90 degrees. That's going to be going back and forth along the y-axis, like this. If I set it to 0 here, the angle direction will go back and forth horizontally along the x direction. If I do anything between 0 and 360 here, let's say 45, it'll do a 45-degree angle cut in this direction across the part. So I have it set to 90, so it'll follow the curves. I set the step over, let's go 10 thousandths. And that should be about it. I'm really not setting the rest finishing option for this one. I'm just computing the planar toolpath. And we'll look at it in our simulation. I'm going to skip all the milling operations till we get to the planar toolpath.
Yeah, B27, that's 10 years ago. Yeah, 2015.
And this is from the roughing operation. When I turn off the toolpath, I can see all of the material removed here. You can see all the weird colors here, like drilling. There's this pink color. This one's a light blue color. That's because it normally has it set to, under the analysis tab, there's a bunch of different options here. I believe that's set to tool number. So you can see what material is being removed from which tool. Next one down is operation number. I think that's what it was set to originally. It'll show you what material is being removed from which operation. And then your deviation page. There's some other options in there, like the bottom is gouge and excess. If there's anything if there was a gouge, it'll show you a different color based on the model that you have pulled in. And then excess is a different color. So if you wanted to maybe leave that at red in threshold, you can change the color by double clicking on each one. And let's go with green for in threshold, and for excess, let's go with blue. And then I can hit refresh to see those colors. I like the deviation page because it has plus or minus 8,000s for the deviation specifically, and all these different colors based on different variations of your stock remaining. And so I'll hit run for the planar toolpath. Slow it down so I can see it run. And you can see the planar toolpath go back and forth across the bottle shape here. You can see the corner right here is based on the corner radius of the tool. So there's about 25 thou remaining in the corners. And that should be about it in here. Once I run this, and the tool goes all the way across here.
That's when you deleted that A from the line 11.
So yeah, if you guys have any questions with what we've gone over today, please let me know in the comments section before we cut it early today. Just got some simple topics, but they can be really useful, really powerful tools like the rest machining to be able to, again, save time and reduce wear. So it'll cut down on cycle times because it will eliminate any air cutting based on your previous stock that you're using. And the drill tip position option can really benefit with reducing wear so that it will start at that exact location that you drilled your hole into the stock, and be able to start from that position, entering into the hole and milling out with the side of the tool from there.
Oh, is that what you were waiting on?
All right, David's got a question. So in a single feature, if you are doing both a rough and finish operation, would you even use rest machining? Good question. No, because, and I'll answer that, no. You have your roughing operation in 3-axis. It bases it off of our original stock that I have selected here. So it's just a rectangular block, just a blank, and it just removes the material from the stock that I've created here and cuts down to the geometry I've selected. Just removes as much material from that stock. Then in the 3-axis finishing, the 3-axis finish toolpath doesn't really bother with the stock here. It just focuses on finishing on the surfaces of my geometry that I've selected. So no, not necessarily. I don't use the rest machining in those options. I usually use the rest machining in a finish operation, so that if I've got sort of like a rough and then a semi-finish and then a finish, that sort of intermediary operation in between the rough and finish, that's when I usually focus on the rest machining option, to be able to eliminate more material in between the rough and the last finish operation, the last finish pass there. So rest machining would be more when you do a tool change, like to a ball mill. Yes. So it would be like if you've got a 1/2-inch flat end mill, then you're using a 1/4-inch ball end mill, and then maybe going down to finally your last tool that you're using, this sort of semi-finish operation you can use with rest machining and just machine from what you've left off with down to what you can with this tool, and then finish up with the last finish operation there. But yeah, good questions there. I use it most of the time for sort of like a semi-finish operation, and then come back with a finish pass. But yeah, good question. And let me know if you guys have any other questions there. We have a webinar every other Wednesday. So today's August 6th. Our next one's going to be August 20th. The topic's still sort of to be determined. We always send a survey out to see what you guys would like to see in the next webinar. So if you guys get those surveys after the webinar today, make sure to fill those out so that we can tailor the specific webinars to your specific topics that you like to go over. And on our support page, when you go to, I'll just show this real quick as well. When you go to bobcatsupport.com, you can go to training, and right above the virtual training schedule, we have recorded virtual events. So we have a whole lot of topics that we've gone over. We've uploaded over the past few years all of the different topics that we've gone over in our webinars as well. These are all of our recorded webinars on milling, lathe, mill turn. Scroll down, you've got wire EDM, Bob Art, how to use the Bob Art program, laser, plasma, and water jet videos as well. So a whole lot of topics that we've already gone over, and then we have our virtual training schedule, which has a bunch of other videos past the one that we've gone over today, that we've done before this one. All right, so I'll hang back and see if you guys have any other questions from what we've gone over today, just the rest milling. So it was rest machining on roughing and the finish operations. If you do multiple finish operations, does each one remember what the previous operation's stock removal? No. So this is sort of what we're going over today. That's a good question. So if we go back to the feature, let's say I did an advanced planer and then I add an equidistant operation after that, it doesn't understand. So if I look at this toolpath first, the planer toolpath, and then I compute the equidistant toolpath, you can see it'll try to do everything that I've already finished with a planer. So that's where the rest machining operation is best utilized, where you can simulate after the planer toolpath, go into the save stock option. So we'll look at that icon again here. I can go through the drilling operations. Once it loads up, I'll hit next stop until I get to my roughing. And then the very next operation after my planer toolpath. Then I can go to cut sim, save my stock model, and I'll name it webinar 2. As an STL file. That way I can close out of simulation. And then here's where we have our rough, we have our advanced planer, and then right below the equidistant toolpath, I'll expand those options where we have our boundary, we have our operations stock here, where I right click, go to reselect, and then I select my STL file. And that's my webinar 2 STL file. And you'll see the webinar 2 STL file will be a little bit more detailed because, that's after the planer toolpath. And I'm going to compute the equidistant toolpath. Should only do maybe a few passes in there because it's only going to clean up the rest of what it's done from the planer toolpath from there. So yeah, each one doesn't remember the previous operation stock removal unless you go in, either do the operation stock or you go to options and your rest finishing, and it understands the previous tool that you used, and then will compute the toolpath based on the previous tool that you used there. And you can see when I hit compute, it's saying that the tool diameter should be greater than the, okay, I use the same tool, so I'd have to do maybe like an 1/8 inch ball end mill here. For my equidistant, it has to be smaller than my planar toolpath that I used before it. And now you can see in the equidistant toolpath, based on the operation stock, based on this stock file, it's only going to create these couple passes in each corner there on both sides of the bottle shape, because it's already finished everything that it can with the planar toolpath, and then just focus on those two areas. It wouldn't understand that unless I brought in the operation stock from my simulation. All right, so thank you guys for asking those questions, and let me know anything that you may have had questions on. If you have any other questions with what we've gone over today, the rest machining, or anything else in general with the software program, go ahead and let me know there. And I want to thank you guys for viewing the webinar today. Yeah, David, good question. Usually it should ask for your email address, and then it should ask first name and last name. You don't really have to type in last name, but if you want to type in your first name there so that you guys can let me know, who I'm talking to, because, I always remember who I'm talking to with tech support. So it's good to know what who's asking the questions and what your questions are, so that, next time you call into tech support, I can help you guys out from where we left off from the webinar. Try to remember what you guys' questions were.
Yeah, not a problem, Joe. We'll talk to you later, man.
Yeah, you may have to register another time. I think you can register with the same email address. I've done that before, just registering with the same email address again, just to update that info. And then when you sign in, you'll have your name in there. So there's the toolpath, and there's the 3D model that we've gone over today. All right, I want to thank everybody for viewing the webinar today. I was on rest machining, and it's in our Mill 3-Axis Pro operations. If you wanted to upgrade, or if you wanted to upgrade to the Mill 3-Axis Pro, or upgrade to any of the other modules that we go over in the webinar, you can call us, and you can, pay the difference basically to upgrade to the module that we've gone over with the Mill 3-Axis Pro, or any other webinar you may have seen. So, excuse me. So thanks again for everyone viewing the webinar today, and hope to see you in the next one. That's going to be August 20th, 1:00 p.m. Eastern Time. All right, thanks everyone. See ya. Have a great day.